Hi, today we'll be covering Module 2, Lesson number 1. The first topic in this lesson is that of equivalent fractions, and what you should look at first here is the fact that we have these two rectangles on the left, and they are in fact both the same size. The top rectangle is cut into 15 pieces and 6 of them are shaded. The bottom rectangle is cut into 5 pieces and 2 of them are shaded. Okay, and since they both reflect the same amount shaded, we can say that those two rectangles represent equivalent fractions. Two fractions are equivalent if they have the same value. The same part of each rectangle is shaded. So we write the equivalent fractions 6 over 15 is equal to 2/5. And then our note here that we can write 2/5 as 6 over 15 by first multiplying it by 1, which is equivalent to 3 over 3, and that's where we can get our 6/15. 2 times 3 is 6, and 5 times 3 is 15. Now, looking at the examples where we need to find the missing number to write equivalent fractions, where we would start here is noticing how do the denominators in part A differ. 20 over 100 is the same as blank over 5. Well, if I focus first initially on the denominators, 100 and 5 differ by a factor of 20. Okay, so what I can do here is I can take my left-hand fraction, 20 over 100, and write that as 20 times 1 over 100, over 20 times 5. 20 times 1 is 20, and 20 times 5 is, in fact, 100. And then, kind of going in the reverse of what we have above, 20 over 20 times 1/5 is equal to 1 times 1/5, which is equal to 1/5. So what we've shown now is that we can start at the left-hand fraction and work our way through to get the right-hand fraction. The denominator is the same. They both have a denominator of 5. So that would mean that the numerator, the missing number, is in fact the 1. Okay, looking at part B, we have 2/3 equals blank over 21. And again, focusing on the denominators, they do differ by a factor of 7. So we can also start with our left-hand fraction and initially multiply it by 1 and rewrite that 1 as 7 over 7. 7 divided by 7 is 1. And now multiplying in the numerators, 2 times 7 is 14. And then in the denominators, 3 times 7 is 21. Okay, so now we've shown that 2/3 is the same as 14 over 21, so the missing number in this case is 14. Now going on to part C, we have 5/6 equals 45 over blank. Now we're going to be looking at the numerators. 5 and 45 differ by a factor of 9. 9 is the missing factor. So we'll do this one the same as we just did A. We'll start with our 5/6. And initially, we're going to multiply that by 1, but we'll rewrite that 1 by as the missing factor, 9 over 9. And now 5 times 9 is 45. That's what we saw initially. Over 6 times 9 is 56. So in this case now we have that the missing number is 56. Okay, now we're going to move on to simplifying fractions. And a fraction is in simplest form when the numerator and the denominator have no common factors. Part A, we're looking at the fraction 42 over 60, and we're going to find a common factor in the numerator and the denominator. Okay, It doesn't matter if I find the largest common factor first, just so long as I find a common factor. So what do I mean by the largest common factor? The GCF, the greatest common factor of 42 and 60, is 6. So if I rewrite the numerator as 6 times 7, which is 42, and the denominator is 6 times 10, 6 times 10 is 60, then we can rewrite this as 6 over 6 times 7 over 10, which is 1 times 7 over 10, which is equal to 7/10. Essentially, we have taken that 6 over 6 and canceled that factor out. But I've shown each step in that the 6 over 6 becomes a 1, and 1 times 7/10 is 7/10. Looking at that bottom example, we have 35 over 100, and I can take my 35 over 100 and rewrite that as 5 times 7 over 5 times 25. 5 is a factor of both 35 and 100, and breaking that 5 over 5 off, times 7 over 25 is equal to 1 times 7 over 25, which is equal to 7/25. Okay? So now in these two examples, we've represented these fractions in their simplest form. They have no common factors other than the number 1. So the fraction 7/10 can only has a greatest common factor of 1 in the numerator and the denominator. Similarly, 7/25 only has a factor of 1 in the numerator and the denominator. Okay. The third part of this section, we're going to be looking at multiplying fractions and mixed numbers. Now, if we look at 4 steps to multiply fractions, we want to first make sure that if there's a whole number, we can write that whole number over 1, if there's a whole number in the problem. Second, if there's any mixed numbers, we're going to convert them to improper fractions. Third, when we multiply the numerators and get the new numerator, then multiply the denominators to get the new denominators, and then finally simplify if needed. Looking at example A here, we're going to first pay attention to that first step. We don't have any whole numbers. The second step, we don't have any mixed numbers. Now the third step, we'll multiply the numerators, 0 times 5, to write the new numerator is 0. We'll multiply the denominators, 6 times 7, to get 42 as the new denominator, and then simplify if needed. 0 divided by 42 is in fact 0. Example B, 1/2 times 2/3. We're going to multiply the numerators, 1 times 2, to get the new numerator, which is 2. Then we'll multiply the two denominators, 2 times 3, to get the new denominator, 6. And now simplify if needed. 2/6, there's a common factor in the numerator and denominator of 2. So I can write the numerator as 2 times 1, the denominator as 2 times 3. Break that 2 over 2 off, times 1/3. And then our simplest form for this fraction is, in fact, 1/3. The 2 over 2 is equal to 1. Okay. Example C, 4 times 5/7. We first notice that the 4 is a whole number, so we can write that over 1 times 5/7. And now we go through our multiplying steps. 4 times 5, 4 times 5 gives the new numerator, 20, and 1 times 7 gives the new denominator, 7. Now we can leave that as an improper fraction, 20 over 7, or we can convert it to a mixed number, which would be 7 into 20 would be twice, with 6 left over. So as a mixed number, that's 2 6/7. Now example D, we are dealing with mixed numbers. So we have an initial step where we need to convert them to improper fractions. So we take our 5½ and convert that to an improper fraction. 5 times 2 plus 1 is 11 halves. And we're multiplying that by 3 3/5. 5 times 3 is 15, plus 3 is 18 fifths. Now we can multiply 11 over 2 times 18 over 5, 11 halves times 18 fifths. And we will multiply our numerators, 11 times 18, to get the new numerator, which is 198. Multiply our denominators, 2 times 5, to get the new denominator, which is 10. Finally, we will convert this one back to a mixed number, especially because we were given mixed numbers, so we want to express our answer as a mixed number. 10 into 198 is 19 times, with 8 left over. So 19 and 8/10, which can then be simplified to 19 and 4/5. 8 and 10 both have a common factor of 2, and that's where that 4/5 comes from. Okay, so we had quite a few steps with that problem, but it's of a greater difficulty. Finally, with example E, we have an application problem. A recipe for meatloaf calls for 1/3 of a cup of chopped green peppers. How much is needed to make half the recipe? So what we're really looking at is what is 1/2 of 1/3. And of, in word problems, we can often think of as multiplication. So we're multiplying 1/2 times 1/3. And in doing that, we multiply our numerators, 1 times 1, to get the new numerator, and multiply the denominators, 2 times 3, to get the new denominator, 1/6. And now, since this is in fact a word problem, an application problem, we have units. In this case, the units are cups. So we need 1/6 of a cup of green peppers. Finally, in this lesson, we'll look at dividing fractions in mixed numbers. Okay. The first thing initially what we'll talk about is a reciprocal. And what is a reciprocal? Well, all it is, or to find a reciprocal, we just flip a fraction over. So for example, the reciprocal of 2/3 is 3/2. 2 over 3 becomes 3 over 2. And one thing to notice, when you multiply a fraction and its reciprocal, what do you get? Well, let's take 2/3 times 3/2. Multiply the numerators, 6, the denominators, 6, and 6 divided by 6 is equal to 1. So 2/3 times 3/2, or any fraction multiplied by its reciprocal, we get 1. Now, when we divide fractions, we'll look at these 4 steps. If there's a whole number, we write that whole number over 1. If there are mixed numbers, we convert them to improper fractions. Then, we change the problem to a multiplication problem. By keeping the first fraction the same, switch the division to multiplication, and then flip or take the reciprocal of the second fraction. Now, it's important to do this after we've written our mixed numbers as improper fractions. So we change our multiplication problem, we change our division problem into multiplication, and then do the same procedure that we do with multiplying fractions. Okay, so let's see what this looks like in our first example. 2/3 divided by 6/7. If we're going to divide these two fractions, we'll first notice that there are no whole numbers, there are no mixed numbers. So step 3, we keep our first fraction the same, 2/3, change the division to multiplication, and then 6/7, we take its reciprocal, 7 over 6. Finally, we do the procedure for multiplying fractions. 2 times 7 is 14 in the numerators. Multiply the numerators to get the new numerator. And 6 times 3 is 18. Do not multiply the denominators to get the new denominator. And then we'll look to see if we can simplify this fraction, and in this case we can, because 14 has a factor of 2 in it, and 18 has a factor of 2 in it. 2 times 7 is 14, 2 times 9 is 18, and if we cancel out that common factor of 2, our final answer becomes 7 over 9, or 7/9. The second example, B, we're dividing 3 by 9/20. Now, step 1, if there's a whole number, we're going to put that whole number over 1. We certainly do have a whole number, so our first step is to write that as 3 over 1 divided by 9 over 20. Now we can change that division problem to multiplication. 3 over 1 stays the same, and we multiply by the reciprocal of the second fraction, which is 20 over 9. Finally, we're going to use the procedure for multiplying fractions. 3 times 20 is 60 in the numerator, and 1 times 9 is 9 in the denominator. Now we're going to look to see if we can simplify these fractions. In this case, we can. 60 and 9 both have a common factor of 3. 9 is 3 times 3, and 60 is 3 times 20. So we can cancel out our common 3 and write this as 20/3. There's our answer as an improper fraction. And we can also take and write that as a mixed number. 3 goes into 20 6 times with 2 left over. So as an improper fraction, we have 20/3. As a mixed number, 6 and 2/3. Now we're going to look at this last example here where we're going to have quite a few more steps because our numbers are given as mixed numbers. Our first step here will be to take these two mixed numbers, 5 and 1/4, 4 and 1/2, and write them as improper fractions. And we have to do this first before rewriting the division as multiplication. Okay, so the 5 and 1/4, 4 times 5 plus 1 is 21 over 4, divided by 2 times 4 plus 1, 8 plus 1 is 9 over 2. Okay, so that's got to be the first step. Change the mixed numbers to improper fractions, and now we can rewrite our division as multiplication. Keep the first fraction the same, change the division to multiplication, and take the reciprocal of the second fraction. 21 over 4 times 2/9. Now we can multiply our fractions using the procedure for multiplication. 21 times 2 is 42 for the new numerator. 4 times 9 is 36 for the new denominator. And now 42 over 36, I can definitely recognize that they're both even. They actually both have a factor of 6 in them. 6 times 7 is 42. 6 times 6 is 36. Canceling out that common factor gives us 7/6, or we can write that in a simpler way, or excuse me, that's our improper fraction answer. We could also write that, and we should also write that as a mixed number, again, because the problem was given with mixed numbers. So we can write this as 1 and 1/6. That is the end of Module 2, Lesson number 1. Thank you.